Good afternoon, class. In today's video, what I wanted to do was to go over the FOIL method. Now, FOIL stands for first, outer, inner, and last. And while you may have seen it in your algebra classes, what I wanted to do was to take it back a step, take one step back, and look at it as just the origins of the FOIL method in and of itself. Because it's not something, it's a useful tool. We've used it in algebra quite a bit, but it doesn't just fall out of the sky. It doesn't just get plucked out of nowhere. So we actually have to know where it comes from and how we can actually, and why we can actually use it. So that's where these examples at the top come from. Then I'm going to go into the actual general case that you would probably see in your algebra textbooks, as well as an example that you might have seen from your algebra textbooks. So let us begin. I start off with a very simple problem of 1 plus 2 times 3 plus 4. And of course, we all know our basic math. 1 plus 2 is 3. 3 plus 4 is 7. So basically we're saying what is 3 times 7, which is 21. None of that is surprising. So that's why it's a great ground to actually test out the FOIL method, because if you can make whatever method you want. You could call it frying pan if you want to, but if it doesn't get you the result that you need, then it's not helpful. So let's take a look at it. So we say it's the first term. So the first terms get multiplied together. So 1 times 3, we put that there. Then we say plus the outer terms, which is 1 times 4, which we put over here. Then we do the inner terms, which is 2 times 3, which we put over here. And then finally we add 2 times the last terms, 2 times 4, which we put over here. And as you can see, I did it with blue marker first, and then green marker to show where in the FOIL method those multiplications are going to be taking place. So from there, we now follow the order of operations, PEMDAS. So we do multiplication left to right first, and then we hit addition. So I simplified this by saying 1 times 3 is 3, 1 times 4 is 4, 2 times 3 is 6, 2 times 4 is 8, and then now you can add the whole thing together and get 21, like we expected. I don't want to make it sound like, wow, this is a new conclusion that we've come up with. No, we've been doing this since elementary school, probably. So keep that in mind. But this method actually does work even for basic skills in math that you would have just done because maybe either you memorized it or you just kind of worked out a different method to just brute force this down. But FOIL actually ultimately comes from here. So there we go. And then, so that's example 1. Example 2 is more of the distributive property. So in this example, what I did was I said, okay, well, 1 plus 2 is 3. And this is, again, not so much the FOIL method, but just to show you how it can be used as, even if you don't want to think of it as just FOIL, or if you want to think of it as distributive property, just a little bit more complex, that's actually fine as well. So 1 plus 2 is 3, and then I leave my 3 plus 4. So now I can take my 3 and, using the distributive property, distribute it to each of the terms here. And so that's what I'm doing. So I distributed my 3 here. So 3 times 3 is 9. 3 times 4 is 12. 9 plus 12 is 21, just like we got last time. So that way of thinking about it actually works. In fact, if you look at what I did over here, that's essentially, FOIL is essentially the distributive property that I've done 2 times, or twice. Right? I took this term, distributed it to the 3 and the 4, and then I took the second term and distributed it to the 3 and the 4 as well. So something to think about in case if you're looking for the origins of how FOIL works. It's basically the distributive property. So what do we do with the general case? Now, I say that this may be a little bit different than other textbooks. In fact, I think it's a little bit different from what I even have in the notes. And the reason why I wanted to make this a little bit more general is because sometimes, especially in your other math classes, you might find that this x is not always 1. It might be like 2x plus 3 times like 3x plus 2, and you have to actually sort that out. So hopefully this will give you an idea of how to, a broader picture of how to do that. So here we go. In the general case, we have a general polynomial written out as ax plus b times cx plus d. All of them are very different. That's why I said they're a very general case. So if we apply the FOIL method to the whole thing, what we get is acx squared plus axd plus bcx plus bd. And so, of course, that's just a formula. That's great, wonderful, but it's not necessarily helpful unless we actually have an example of what that actually looks like. So then that's why the example for the general case was I took something that probably is in every algebra textbook of x plus 2 times x plus 3, and we don't know what x is, so we're going to have a very hard time actually distributing all of these things unless we use the FOIL method. So using that, we get x times x, which is x squared, then x times 3, which is 3x, 2 times x, which is 2x, and 2 times 3, which is 6. Of course, we have like terms over here, so we can add the 3x plus 2x, so we get our final answer of x squared plus 5x plus 6. So that's how to do the FOIL method. In the next video, I'll work on the reverse FOIL method. So good luck in your studies. May the force be with you.